Welcome back again, guys, to another lecture of DSA. Today, we will take up the topic sliding window technique and we'll try to understand how it works and how we can approach a problem applying the sliding window technique. So, basically, sliding window technique we will usually apply it on like collection list or array. So for example, I have this array like 2 and then 1 and then 3 then 7 and then 4, right? So I have this array with me right now and I need to apply the sliding window technique in this array. Now moving on, what I will do, I will also assign the index here, as you can see. And what we will do here is we will consider a window size, right? So we also got something called as window size, where we will be considering a window size of k value, right? So k value is nothing but the input that the user gives. Suppose I give k value equal to 3. So the window size here that I will check is 3. That means I will consider 3 consecutive elements, or you can say it has to be consecutive, right? So one element has to be next to another element and so on. So 3 consecutive elements I need to consider inside the window, and that I have to calculate the sum. So here the sum will be how much? 2 plus 1 plus 3. So I have got 6, right? So our first window is of size k value 3 is how much? 6. And likewise we have to go till the end, but the thing is here what we need to find out, what is the main right, the target, right, final output, or what kind of result are we targeting here. So basically we are targeting the maximum out of all the window size, right? So whatever the maximum which I get at the end, that we will consider. So that is how our sliding window technique works. And here now next, moving on to next window this thing. So here we have again got this 137, right? So previously 213 was 6. Now we will calculate for 1, 3 and 7. So this will come how much? This will give me 11, right? So now 6, if we compare 6 and 11, we obviously know that 11 is greater than 6, so we will consider 11 for now. Likewise, again, we will increment, right? We will move one element to the right. Now, what we will consider? We will consider 3, 7, 4. And this is our last sub-array, right? If you see 213, 137, and 374, out of all the k size window size, this 374 is the last sub array that we can think of in this array, right? So now let's sum it up, 3, 7 and 4. So how much we are getting? 10 plus 4, 4, 14. So again, if you compare 6, 11 and 14, obviously 14 is the maximum sum that we can benefit out of the summation of 3 consecutive elements, right, from the array. So that is how sliding window techniques works. So we will club according to the window size of k value, and we will club the sub array and sum it up. And likewise, after summing it up, we will again proceed to the next sub array, right? So likewise, we will go till the end of the array. So the last sub array, it is giving me 14. Since it is giving me 14, we will consider 14 as the maximum. So this is our final targeted value, right, in this particular array. Now you got the overview of sliding window technique idea. Now what I want to do is, how do I solve this sliding window technique? So first thing first, I will be considering the brute force approach, right? So always when I'm trying to solve some kind of DSA, I will always consider the brute force approach. Then I will try to optimize it for our minimal time complexity. So when we consider the brute force approach, right? So let me first jot down this array. So 2, 1, 3, and then 7, 4. So yeah, here is our array, and let's try to apply the brute force approach here. So this is basically my array for now, and we will just assign the index also, and this is the index that I'm assigning here. Now how will I solve this using the brute force approach? That is the main motive here. Now what I will do, I will try to control this outer index, right, using the for loop. So for loop, if I go from I equal to 0, then I will go till which value? Suppose my k value is how much? 3, right? Suppose the k value is 3. So what I will do, I will go I till well, I will go till k, right? I will not go till n. So this is my n. Let me change. This is my n, and I is going from 0 till n, right? So it will not go to the last one. It will go n, then n minus 1, then okay, n minus 2, like that it will go, right? So this is how it will iterate with the I. And here okay, let's try this with the Python for loop actually. So here I have for I in, and then till where it will go, length, right? So I need to take the length ARR minus k plus 1. So this is the outer loop, okay, that will control the iteration. So what is the size of array? The size of array is basically, here it is how much? 5, right? Because we counting 1, 2, 3, 4, 5. We have 5 elements here. That is the length or size. Minus k is how much? K is 3, right? And then plus 1. So how much it will give me? 2, and then plus 1 equal to 3, right? So 0, 1, 2, 3, right? So it will go till 3 actually. But since this is a Python, we are writing in Python, it will not go till 3. We will not consider the last index. We will consider the last second, right? Since this is a what? Since this is a Python that we are writing. So it will go to 0, 1, 2. And if you see here, 2 is the starting of our last sub-array index, right? Because k is 3, so we are clubbing three elements together as a sub array. So our first sub array becomes what? Our first sub array becomes this, then the second sub array becomes this, and our last sub array becomes this one, right? So now if I'm running this loop, this will go till where? This is going till our starting of the last sub array, which will be index 2, and the value is 3 here, right? So I hope that is understood for our first loop, that is controlling. And then again we need to write within this loop, we need to write another loop, because we are using the brute force approach, right? So now we will go j, and j will go till where? J will go till k, right? So j will go till k. Fine. So why? Because we want to go from 0, 1, 2. We want to count 3, 3, right? Because the size, window size is 3, because the k value here is 3. So j is going from 0 then till 2, right? Because k value is how much? K value is 3. So we are not considering in Python the last. Instead of that, we will consider the last second. So which will be 2, right? So 0, 1, 2. So if you count from 0, it is again it is counting till 3, right? So 0, 1, 2, which is of, right, 3. So here in Python, always we will not consider the uh, last index. Suppose I give here 3, so it will count till 2. So 0 till 2 it will go. Right. So J also is iterating. Like J is also iterating, and always what happens here is time complexity matters. So what is the time complex? What will be the time complexity here? Time complexity here will be for this one, the length of array we will consider n, right? Because from 0 to n it is going, so time complexity is n, then minus k, then plus 1. So plus 1 is a constant, so we will discard this, and then followed by what? Followed by into this one, right? So this one is what? This one is k. So it is going till k, so we will consider k into k. So now we have nk minus k square, right? So again, if we calculate this, then this is coming how much? K square is very small constant, so we can also discard this. But here we are left with big O notation of nk, right? But here this is again bad. This is again bad time complexity. Why? Because k can be anything. K can also be n, right? So if k becomes n, then n into n, that becomes n square. So O n square again it can become. So we are not going ahead with the O n square always. We will go ahead with O n, which will be the optimized one. So this was the brute force approach without using any, any optimization or any sort of, approach, like optimization approach. But now we will try to optimize this to bring it, the time complexity little bit down, right? So next, what we can consider is using the sliding window approach. So what basically sliding window approach is saying is that instead of running two loops like this, we will be running only a single loop. And in that loop only, we will try to calculate the maximum value of the subarray summation, right? So here again, what I will do is I will write the loop, right? So I will write the loop, and the loop will go till where? The loop will go till, okay, so the loop will go till the starting of the last sub array. So our loop will go till the starting of the last sub array here. And before that, what we will do is we will simply calculate the okay, we will simply calculate this. We will first calculate this sum, right? After that, we will go forward.